All right, guys. So today I'm going to introduce you to the world of complex numbers. Now, with complex numbers, what I'm referring to are numbers that are both real and imaginary. Now, the first thing we got to get away, a little background. Imaginary is a misnomer. They are not imaginary. They are real numbers. They exist. They can be used mathematically to prove physical phenomena. They can be used to explain physical phenomena. It's not that they don't exist. It's that they exist in a different frame of reference. Okay, let me explain this to you. Let's say that we go out into the depths of some place somewhere and we find an indigenous culture. Now, this indigenous culture can explain the numbers 1 and 2. If you go up to them and say, I would like to buy 1 sheep, they can sell you 1 sheep. If you want to buy 2 sheep, you say, I want to buy 2 sheep. If you want anything more, then the word that they have is simply many. They don't have a word for 3 or 4 or anything else. It's just if it's more than 2, then you say, I want many sheep. There's no way to explain that. That never mattered to them because whenever they bought stuff for their family and close friends, and they only needed 1 or 2 sheep. They never needed more than that. So any more than that is just many. All right, now I go with a group of 100 people and say that I need to feed my family and make clothes and I need 5 sheep. Well, what do? If I say many, that doesn't mean anything to them. It's just more than 2. So what do? I teach them about 3, 4, and 5. I come up with numbers that represent something more than 2. Now, after 5 is many, you can extend this on to all integers. But, what if, say, my family decides they don't like this indigenous place in the middle of nowhere, and they all leave me to live by myself. Now, I'm by myself. I go to the market. I'm not going to eat a whole sheep, right? I only want half of a sheep. They don't have a number for that, though. They don't understand that I don't want a whole sheep. So how do I explain that? Well, we have to create a new number. We create the idea of a fraction, 1/2, or a decimal, 0.5. Now, you can kind of see how this idea could extend. Eventually we want to be able to show that we owe people sheep or owe people money or whatever it may be, so we introduce the idea of negatives. You introduce the idea of fractions. I don't even want half a sheep. I just want, a certain number of grams, so we introduce all these other things. All right, well, what about when we get to the idea, all of these things in mathematics are just constructs, ways that we've come up with to explain what's happening mathematically. All right, and so we've already gotten to the point where we know lots of things now. We know about quadratics, we've got exponents, which we created so that we don't have to, multiply things several times. And with lots of mathematics that we've got, things that we've explained, right? Exponents, even multiplication, so I don't have to add 2 plus 2 plus 2, right? I just go 2 times 3 is 6, right? All of these things, square roots, logarithms, all of these things are artificial constructs that we've created so that we have a way to explain something that we see either in observation or something that we use. Now, what is imaginary? What are imaginary numbers? Well, it's just at some point, I probably should figure this out, but I don't know. At some point, somebody came across the square root of a negative, and they said, you know what? I would like to be able to continue this problem. I would like to be able to continue this and see where it leads me. So they created an artificial construct, just like 3, 4, 5 are artificial constructs. They're these abstract symbols representing numbers. Same thing. How do I represent the square root of a negative? Well, I can't do that with the numbers that I already have, so I create something else. And the person that created it just so happened that he decided to call it imaginary. And so what he said, well, you know what? I can take the square root of a -1. The square root of a -1 is I. Or, in other words, I squared is equal to -1. And once I have that, I can now take the square root of -4 because I can square root -1 times 4. This is what we're doing every time that we do this. I can square root the -1, which is I, and then I can square root the 4, which is 2, and so I get an answer of 2i. So that's kind of the idea. imaginary numbers are not really imaginary. They're just as real and just as important as real numbers. We just don't call them as such. It's a misnomer. All right?